Now. So again, I'm Grzegorz, or if you prefer, just Greg. And at some point I had to protect some assets using AppLocker, so I decided to dig a bit deeper, scratch the surface to identify if AppLocker is for shoot good enough for our things. And what I would like to cover today, two AppLocker internal mechanisms giving you somehow unexpected results. So let's go for the first one. When it comes to the AppLocker itself, AppLocker consists of a couple of components. Of course, we have some management. It is a kernel-based mechanism, but it stores its own database. It is managed from user mode. There is a special service translating the database from the user mode to the kernel mode. There's the AppID SVC, which must be running to have AppLocker running, but the full thing within AppLocker protection is done by the driver running within the kernel. AppLocker can work in enforcement mode, meaning non-listed apps, non-whitelisted apps are not allowed to be run, and in the audit mode, meaning any single application will run, but there will be a warning within the log telling me it would be blocked if I play seriously. When it comes to rules AppLocker can use, first very big thing about AppLocker, comparing for the example to WDAC, is it can rely on user identity. But generally saying, rules can be made for a path, so if the path matches, the application is allowed or not. A rule can be made based on a hash, so the hash of the file is being calculated, and if the hash matches, the application is being allowed, and on the digital signature. I will focus on hash rules, as those are the simplest one to show you today what I want to show you. Okay, let's go to the imperfection number one, because generally saying, I have my AppLocker up and running, it is working in the audit mode, I can quickly verify it here, going to properties, I can see it is for executable only, configured within the audit only mode, and I have kind of a typical configuration, meaning if something is within the program files, it is allowed to be run, as regular user cannot drop software there. And if something is within Windows folder, it's also allowed to be run. If I run anything, let's do this with CharMap, my favorite is even better than calculator. CharMap is up and running. If I go to the event log, F5, I can see CharMap was allowed to run, which is quite obvious as it stays within the Windows folder. Usually, for the simplicity, when AppLocker is being deployed, at least at the initial stage, we are not deploying rules for DLL files. We are focusing on executable files on exist only because it is simpler. When we go deeper into the AppLocker, we can realize one thing. If within the token of the process there is a seed present, S156, AppLocker totally ignores such executable file. So I can steal such token, or I can use a trick allowing me to have such token without being blocked. I will elevate my process using this token using a DLL. So it will be basically run DLL32, as this one is allowed as is in the Windows folder, and I rarely can find environments where it can be actually blocked. And then there is a DLL, ignore applocker.dll, there is a function, do it, and then C Windows System 32, and then CMD, and the CMD is being launched. If I try to investigate what is inside, whoami/all, I can find the seed I mentioned as 156 here. It is a special seed for a service. So I have launched first process right now. I can say the second one, the CMD itself, the whoami process, I can launch whatever, notepad. It is allowed. On my desktop, I have yet another special application, write AAA, a special application writing 100A letters, which is perfectly well working. If I refresh the log, absolutely nothing about this is appearing within the log. The last thing that appeared was run DLL, which is allowed absolutely everywhere. So if you are able to launch a process having S156 within the token, it will be just ignored by the AppLocker. Not enforced, not logged, not audited, not blocked, whatever. It will just totally ignored, and it is for this single particular seed. So it is good to monitor somehow if you have a process running with this seed. Under normal conditions, it is only about services. It is a legal seed for services, but not for interactive applications, so you have to find your way to monitor somehow. Okay, let's go to the second AppLocker nice thing. It's about the speed. Because I mentioned hashes. Calculating a hash is somehow, I would say, time-consuming. Why? Not only because of the calculation itself, but about the need of reading entire file from the disk. Windows introduces prefetch, etc., all for the speed. At the same time, using AppLocker with hashing every single executable file or DLL file being launched would slow down the computer significantly. So I will create a rule based on hash for the file I already have run. So create a new rule. Next, allow for everyone. File hash. Next, browse files. I will go to my file. I have it on the desktop. This is the one. Write AAA. Open. Next, create. I have a rule for it. If I will close this one as this one is ignored anyway, I will go here. I will run this piece of code. Write AAA. 100 letter A appears on the screen. F5. It was allowed to run right now, which is perfectly according to our expectations. What I will do now, I will do a virtual way of unplugging my hard disk, manipulating it on another computer, and then plugging it back to my laptop. So how I will achieve this? I will go here, attach VHD, and then the name is xVHDX, and new X drive appears within my system. I will go here, I will copy write IAA into the X drive. It was copied. If I run it from the X drive, obviously it will run, and it will be allowed to be run X write IAA because the hash clearly matches. I will manipulate this disk offline right now by detaching the VHD, yes, going to hex editor, loading the VHD, finding the pattern, it is here, and I will replace the pattern within the executable file, a couple of my A letters with a X letter. Close, reattach it. Sorry, it is C temp xVHDX. Okay, it appeared again, and I will run the same X write IAA with the image being manipulated offline. And not a big surprise, I have a couple of X letter over here. Do the hash of the executable file match the previous one? Not really. If I take a look into the log, over here, F5, here, hex editor was not allowed to be run, not a big surprise, but the write AAA, the manipulated one, was perfectly well allowed to be run. It means the hash of the file is being cached somewhere. I will try to find it. Okay, let's go for the hashes first. CLS, and I will go PowerShell and get file hash for write IAA. The original one, still staying on my desktop, has a hash D35 and so on. The manipulated one, get file hash X write IAA, has a totally different one, which is not a big surprise. It is just a different executable file. Let's take a look on the PowerShell rule, on the AppLocker rules right now. So it would be get AppLocker policy local, and then to XML. And here I can find the hash being allowed. Does it match any of those? It is SHA-256, obviously. It is something else, not the first one, not the second one. It is because the beauty of the AppLocker, it lies about the hashing algorithm. It is not SHA-256. It is so-called, it is not officially stated, but it is so-called executable hash or authenticode hash and so on. The algorithm is documented, but no one is clearly saying AppLocker is using it. So it is yet totally different hash. By the way, if you have hashes of your files and you want to create AppLocker rules based on your hashes, you will fail because AppLocker will not use real SHA-256. There is undocumented XML parameter called SHA-256 flat, being actually SHA-256. At the same time, I would not rely on this too much, as it is undocumented. So, how to calculate this hash if you have a file? Get AppLocker file information, and then you can specify a file, and the hash you can see only the beginning. I will not format it nicely over here, but you can see it is exactly the hash over here, not being SHA-256 at all, despite what Microsoft is telling us. Okay, so this is about hashing algorithm. Now about how the hash is being stored, where is the hash, and how it was manipulated. The hash for AppLocker is being stored within so-called NTFS extended attributes. You can think about NTFS extended attributes somehow like you think about alternate data stream. It's not the same, but it is somehow comparable. It is kind of alternate data stream on steroids and so on. So if you want to display, I will exit my PowerShell. If you want to display extended attributes, I will launch one console more. It will be useful in a moment. Desktop. FSUtil file extended attribute FSUtil file, and there is a query AA parameter for querying extended attributes. If you specify a file, let's say write IAA, you will see extended attributes displayed over here. You can see the attribute hash info containing a cache of the hash. And if you remember the hash, the one visible over here, 6E3 and so on, you can clearly find it over here as well. This is the AppLocker hash of the file being stored within the extended attribute. So if you manipulate the file offline, the extended attribute is not updated. There is no reason of doing it. And it means that the extended attribute contains the old hash, which is perfectly well trusted by the AppLocker driver. So, how we can manipulate the hash slightly better way is not that easy. The idea of extended attribute is, I would say, well documented. And there are two things over here within the name of the extended attribute. The first thing within the name is the $kernel. The attribute, if the attribute name starts with the $kernel, it is allowed to be manipulated only by the kernel modules. So you cannot create, manipulate, change, delete, whatever, such attribute from the user mode. It is why it may be easier to manipulate the drive offline, or if you want to plant your own driver into a kernel, up to you. Another thing within the extended attribute is the part of the name. When you can see the part within the name after $kernel, it is a signal for the ntfs.sys driver, telling ntfs.sys driver if the file content is being manipulated anyway, the extended attribute must be removed totally. It is why I cannot change the file online. I have to go under NTFS driver. If I can do this online under the NTFS driver, it will be perfectly legit. For my purposes, doing it on the VHDX drive is just simpler and easier to demonstrate. So if I manipulate the file, the extended attribute will disappear, and if I run the file again, the hash will be calculated, the new extended attribute will be established, and AppLocker will start relying on this extended attribute. I know manipulating the string within the file, it is not that complex, but sometimes it may be, sometimes maybe something more sophisticated is needed. For this purpose, I can plant this particular hash within the extended attribute. So I will copy my hacking application to the X drive, and I will use set AppLocker hash cache file I have created for the X my hacking application, and I will place the hash over here. I'm doing a simple trick here. As I said, I cannot create a $kernel extended attribute. It is not allowed for mere mortals. At the same time, I can create a hash kernel and so on extended attribute, and this is what I did, and I'm displaying a nice message. Now it is your job to rename it somehow from the hash kernel into the $kernel. So to do this, I will again detach VHD. Okay, I will again run a hex editor, reopen the same file, and use Ctrl-R for replace, and I will replace hash kernel dot into the $kernel dot replace all, and it was replaced. You can see it was this occurrence, so it is probably the right one. It was the hash. Something would be dollar something. I will close it. I will reattach my virtual drive. Attach c temp x vhdx. Again, attach. Once I have edited one file and attach another one, it is even worse than misspelling the path. C temp x vhdx. It appeared. I have my hacking application x pwn.exe. It ran. If you take a look into the log, it was perfectly well allowed to be run, even if it's obviously it should be obviously being blocked by AppLocker. This warning is about the hex editor, which for reason is being displayed here as it's not covered by any rule, so it is not effectively allowed. So what does it mean? We can manipulate the stuff. AppLocker is using some undocumented internals. The first one I would mention is it is ignoring S156 processes when the token has S156 on the list on the group, being very precise. The second thing is it relies on hashes, and the hash does not really match SHA-256, even if AppLocker tries to tell you so. The second thing, it relies on the cache of the hashes and on the cache of the digital signature as well. because for the hashes, it doesn't look like very practical, but we can use exactly the same technique and it will work to falsify the digital signature of for Microsoft, for example. Because if the file is being digitally signed, here you can see, where is my F7? Okay, I will type the very complex command again, fsu till file query AA X write AAA. If the file is being digitally signed, I have digitally signed my application, the digital signature will be stored within the AID3 stream, and the extended attribute will be called kernel purge, not very surprising, app ID for AppLocker, and then signer info. You can manipulate this particular piece of information as well, effectively meaning that if you are using AppLocker, probably you whitelist some applications on the digital signature. Very common practice is to whitelist Microsoft things, because Microsoft tries to store stuff within the user profile, update, and so on. So it is safe to whitelist anything from Microsoft. Effectively, if you are able to offline put such cache information about Microsoft signature onto a file on the offline media, if you plug the media in back, and if you run the executable file, AppLocker will believe it is perfectly legit because it is digitally signed by Microsoft. By the way, yet another beautiful thing within AppLocker. We have a PowerShell commandlet about testing AppLocker policy. Test AppLocker policy, you have to specify XML file and then executable file name, and you will see if this file will be allowed to be run or not really. The test AppLocker policy commandlet is using a real calculated on-demand hash of the file and not the stored one. So it is perfectly possible to see, I will not export XML policy and so on, but it is very easy. My file with the manipulated hash will run as AppLocker will trust it. If I test it through PowerShell, I will see information it will be not allowed to be run, because the test command relies on the real content of the file, and the AppLocker itself relies on its hash. They went too fast a bit, I will say. When it comes to resources, there is a short write-up somewhere. There is a file for copying extended attributes from one file to another one, something I didn't present, but also working. There is also a short demonstration on YouTube I have recorded. If you are quick enough, you can type it in. If you prefer, go to the list of those links. You can go by the code. And that's basically it. Thank you very much.